Welcome, Maine educators. In this tutorial, we're going to equip you with everything you need to confidently lead your students through the exciting microbit MakeCode dice activity. This project is a fantastic way to introduce fundamental coding concepts while creating a fun interactive device. Now, on the surface, it might look like we're just making a digital cube, but under the hood, this project is really a greatest hits of computer science. It's our bridge between the physical world and the digital one. The first big concept we're tackling is input and output. You are essentially teaching the microbit to feel. When you shake it, that's a physical input. When it flashes a number, that's a visual output. You're exploring a digital nervous system. From there, we will explore randomization. You'll see how a computer, which is usually very logical and predictable, can actually simulate randomness to give us a fair roll every time. And of course, we'll be practicing debugging. Let's be real, your code might not work the first time, and that's actually a good thing. Fixing and finding those bugs is where the real engineering happens. Now, let's head over to MakeCode for Microbit to get you started on our next activity. Okay, now that we're at MakeCode for Microbit, we are going to start working on our dice project. This is a classic rite of passage for microbit creators. It's the perfect blend of simple logic and instant physical feedback. And I don't know about you, but there have been times when I wished I had digital number cubes for my classroom because shaking dice with middle school students can get pretty dicey. Haha, see what I did there? We're going to use the built-in accelerometer to turn a shake into a random number. No more chasing those lost dice under the tables and chairs. Let's get coding. So first thing, once we get into the MakeCode interface, we're going to go up to dice. Click on dice. And again, we're going to use the blocks and we're going to start the tutorial. You're going to get a pop-up screen. Just go ahead and hit OK. And then we'll be ready to go. Remember, teachers, that you have the directions at the top written out, and kids also can access them through the screen reader. And after each direction, you hit next and it takes you to the next direction. So the heart of the entire project is on the shake block, which is already waiting for you, but you could also find it under the input category for future reference. Think of this block as a detecting function. It has a built-in sensor called an accelerometer that detects a change in motion. Explain to your kids that anything we snap inside this bracket stays asleep until that specific physical motion wakes it up. Once we have that trigger, we need a way to see our results. So we'll grab the show number block from the basic category. Okay, but now you're probably thinking, how do we get the number into that box? That's where we're going to use the pick random block from the math menu. We're going to grab that, and that's going to go inside the yellow there, and it will pop right into there. Next, we'll set it to pick a whole number from 1 to 6. You can explain this as the microbit reaching into a digital hat and pulling out a random number. So we're going to use 1 through 6 because those are the numbers on a number cube. And by connecting all of these pieces, the students are going to be able to see the full flow. The sensor detects a shake, the math block picks a random number, and the show block flashes the result across the LED screen. So let's check over here. We're going to click over on the shake button. You'll see a shake on the simulator. Oh, and there we go. It's a 3. Shake it again. It's a 6. Shake it again. We get a 3, a 1, and etc. You can keep that going. It's a clear logical loop that shows exactly how the physical movement turns into a digital result. And as soon as they have finished the coding, have them download their microbits. Obviously, plug them in first. Download them and let them play with their digital number cubes. I'm sure they're going to think of many different ways in which to use this number cube. So today we've seen how physical movement triggers a digital response for the microbit sensors. Your students have used math to simulate real-world randomness and practice the essential skill of debugging to bring it all together. Watching the first number flash across the LED screen is always a light bulb moment. It's the perfect foundation for the more complex games that are possible. Take some time to let your students experiment. Maybe challenge them to see if they can change the range of the number cubes to 10 or 20. I can't wait to see the creative ways they take this logic and run with it. Thank you so much for joining us at Pine Tree Programming. We are thrilled to be part of your coding journey. We'll see you in the next video. Happy coding.